We know that a data lake is a centralized repository that allows us to store all our structured and unstructured data. Many of us have experienced that setting up and managing data lake is complicated, time consuming and require a lot of manual work including loading volume and variety of data from diverse sources like databases, applications, logs, IoT devices, images, videos, and many others in real time, near real time, on demand, or scheduled batch mode. Further, we need monitoring those data flows, setting up partitions, turning on encryption, and managing keys, defining transformation jobs and monitoring their operations, reorganizing data into a calmer format, configuring access control settings, deduplicating redundant data, matching link records, granting access to datasets, auditing access over time, and so on. To execute these steps, one need to have a skills on variety of tools, multi-year experience on data engineering, programming, building infrastructure, securing and controlling access. AWS provides the most secure, scalable, comprehensive, and cost-effective portfolio of services that enables us to build our data lake in the cloud, analyze all our data, including data from IoT devices, with a variety of analytical approaches, including machine learning. I am Alok Pandey, lead consultant, high performance computing, big data, and machine learning at Locus Enterprise Solutions Limited. In this video, I'll demonstrate step by step how we can ingest incremental structured data from PostgreSQL easily to Amazon S3 data lake using AWS Lake Formation. AWS Lake Formation is a fully managed service that makes it easier to build, secure, and manage data lakes. Lake Formation simplifies and automates many of the complex manual steps that are usually required to create data lakes, including collecting, cleansing, moving, and cataloging data, and securely making that data available for analytics and machine learning. To repeat the steps in this video, one need Internet administrator access to AWS console, access to source database including IP, username, password, database and table details, working knowledge of IAM, VPC, S3 and PostgreSQL. Verify source database. Log into your database server and then connect to your database. Verify the database and its ownership. We'll use DBD rental database for our demo. Select database and verify the list of tables inside the database. Verify the content of tables. Please ensure that DB server is accessible from outside. In this section, I'll take you through creation of IAM role and policy required for AWS Lake Formation. Log into AWS console using your administrator account, not by the root account, and search for IAM. On left pane of IAM window, click on roles and then click on create role. In this window, look for glue. Click on glue and then click on next permissions. Under the create policy window, below is the filter policy. On the search tab, type glue. You will see few options of glue access and glue policy. Select AWS glue service role. Click on next text. Tags are optional. You may leave it for now and click on next review. On this window, give the role name. Let's say Lake Formation Workflow role. Now we can leave all other options as default and click on create role. This will create the role named Lake Formation Workflow role. Now we need to add the policy in this role, so click on Lake Formation Workflow role. Under permissions of this window, click on Add Inline Policy. Now we are in a window named Create Policy. Click on JSON to directly edit the required information. Here we need to replace the account ID by our account ID and leave remaining thing as default. This will be like all these 22 lines. We need to just replace the ARN AWS IAM and the account ID that is masked on my screen. Scroll down and click on Review Policy. We need to give the name, let's say Lake Formation Workflow. Scroll down and click on Save Changes. We see Lake Formation Workflow inline policy is added to Lake Formation Workflow role. With these steps, we have created required role and policy. In this section, I am showing VPC, subnets, and security groups configured for AWS Lake Formation. For security reasons, I have masked all the ARNs and IDs. We have created a separate VPC for the data lake demonstration named EA_DL_VPC. This VPC has two subnets, public and private, with Internet Gateway Association to establish the connectivity with the source database which is running outside. Then we have created one security group. The security group having one inbound and outbound rule for self-reference, allowing all ports, which allows AWS Glue to communicate with all its components. Another rule allowing communication with the database server on port 5432. In this section, I'll demonstrate how to configure AWS Lake Formation for incremental structured data ingestion. Log into AWS console using your administrator account ID and click on Services. Go to Analytics and then AWS Lake Formation and click on it. When AWS Lake Formation is used for the very first time in that region of your account, it will ask to add administrators. Click on it. Select your administrator account. In my case, it's username Alok, and then click on Save. A notification message on top shows that administrator is added successfully. Next, click on Settings in left pane. Here is Data Catalog setting. Uncheck both the access control options and save it. Confirm confirmation is displayed on top. Then go to dashboard. We get 3-stage setup process on this dashboard. Click on register location under stage 1 to register Amazon S3 storage as data lake target. Browse for an existing bucket. I have selected the bucket which has already been created for demo purpose. The other bucket on the screen under this account are masked for the security reasons. Leave the IAM role option as is and then click on register location. The confirmation message shall be displayed on top as earlier. These locations further can be verified under data lake locations in left pane. Click again on dashboard. Click on create database under stage 2. We are on create database. Give a name to database. Let's say testdb. Browse for location which is optional. I have browsed the same S3 bucket which we had created earlier. Description can be given for future reference and then click on create database. Newly created database shall be listed in databases. On the left pane, go to dashboard. Now go to stage 3, grant permissions. The pop-up window will appear. Search for IAM role lake formation. Select lake formation workflow role. Search for database. Select database testdb. Click on grant. The confirmation message is displayed on top. Click on data locations in the left pane. Click on grant. New window grant permissions will pop up. Select IAM role lake formation workflow role. Browse for storage locations. Select the S3 bucket created earlier. Click on grant. Upon successful execution of the task, the confirmation message is displayed on top. Now go to crawlers. It will open a new tab and take us to AWS Glue console. Click on connections in left pane. Click on add connections to establish JDBC connectivity with the source database. Give a name. Let's say PSQL_con. Select the connection type JDBC. Leave other things default and click on next. This window will ask JDBC connection inputs. Type the full JDBC URL. You must collect the database server IP, port, user ID and password in advance. Type username and password. Click on choose VPC. You must select a VPC created earlier. This window will not allow to create a new one. Select the private subnet of the VPC. Select the security group. You may select one or more. Click next. Click finish. The window will show you the connection summary. You select your connection to verify the connectivity with source database. Click on test connection. Select lake formation workflow role. Click on test connection. It will take some time and display the status message on top. Message on top says that the connection was successful. Go to the lake formation dashboard and click on blueprints. Click on use blueprints. The window will show various types of blueprints. By default, database snapshot is selected. Select incremental database. Under import source, click on database connection. Select PSQL_con that we have already established and tested. Type the full path of the address table which we had identified to ingest at source. Under incremental data, inside the table name, type the name of the table. Select TestDB database inside target database under import target to ingest data. Select target storage location, which is the registered S3 location. Keep the data format to default Parquet format. Import frequency define how often we want to ingest from the selected table. I have selected Run on Demand. Under Import option, give name of workflow. For example, locus_demo, and then select IAM role. Give the table prefix. It will help us to identify the specific table among pool of tables obtained from various sources and frequency. Leave the other options as is and click on Create. It will take some time to create the workflow. Upon successful creation, one message will pop up and tell you an option to start it. Go to Actions and then click on Start. In few moments, we shall see the last run status running. As soon as it started running, go to Actions and View Graph to monitor the import status. Click on History. Select the running job and then click on View Run Details. It will show the complete pipeline in graph, success and failures. All warnings, errors and success messages can be seen from this window. You can zoom in and zoom out to see a specific detail. When the process gets completed successfully, we'll find all the bar green and run state will get changed to complete. Go to Lake Formation window, click on Databases and then select TestDB. The window will show all the imported tables in the database. We shall see two tables for each import. The classification shows the format and then timestamp when the last successful import executed. Now select the row. Go to Actions and then click on View Data. One pop-up will be shown for Athena to preview data. Click on OK. It will open another window for Athena. Athena will automatically write and execute query to read the data from table. In the result section, it will show the execution status and upon successful execution, it will show the data. You can go to your DB server and match the contents. As a next step, log into your database server, add some data to the source table, rerun the workflow which will read CTC and ingest data to the target, and then validate the appended data in target database using Lake Formation and Athena. In this video, we have demonstrated that how to ingest incremental structured data from PostgreSQL easily to Amazon S3 Data Lake using AWS Lake Formation, which is a fully managed service. We had just pointed Lake Formation at our data source, and Lake Formation crawled those sources and moved the data into Amazon S3 Data Lake without deep knowledge of complex technology. With the Lake Formation, we registered the S3 bucket and path for our data lake, orchestrated data flows that ingested, cleansed, transformed, and organized the raw data, created and managed a data catalog containing metadata about data sources and data in the data lake, defined granular data access policies to the metadata and data through a grand REO permission model. I am Alok Pandey at Locus Enterprise Solutions Limited. Thank you for watching us. Please leave your comments and subscribe to our YouTube channel.